Our next rule is our longest rule that we're going to have the whole semester. Um, so that's all the more reason why you don't want to use it unless you absolutely have to. So this is the quotient rule. The nice part is it's the easiest one to recognize. It looks like a fraction. This has x's on the top and bottom of a fraction. So I think it's easier to recognize than the product rule is. But again, because it's the longest rule we have, you don't want to use it unless you absolutely have to. So something that is a quotient rule would be something like y equals x squared plus 5 over x plus 1. Has x's in the top and the bottom. That's going to be something that we can tackle now, but something that is not, that we've already seen and we did not have to use the quotient rule for, is a fraction, but it's something like 5x cubed, where it only has x's in the bottom. So if you don't have x's in both the top and the bottom, it's not a quotient rule. So this one we would just rewrite. We'd say, hey, we can bring this up as 5x to negative 3, and then we could take the derivative to be, 5 times negative 3 is negative 15, x to the negative 4. So just be super careful. Don't say, well, every single fraction I see from now on, I'm going to use the quotient rule. Don't use it unless you absolutely have to, just because it is such a long rule. So let's get on with what the rule is. We have a function, I'm going to say it's y equals, and I'm going to call it t of x over b of x. You have x's in the top and the bottom, and I'm calling them t and b for top and bottom. You could also say n and d, numerator and denominator. I think the book uses f over g, but that's not super descriptive. The derivative, y prime, is still going to be a derivative times an original, just like the product rule was, but it's a specific order. You have to do the derivative of the top first. Derivative of the top times the original bottom. Minus derivative of the bottom times the original top. Derivative times an original, but this time order matters because subtraction makes the order matter. Product rule, the order doesn't truly matter because you're adding them. 2 plus 3 is the same thing as 3 plus 2. But here, 2 minus 3 is negative 1, but 3 minus 2 is positive 1. So product rule, the order really doesn't matter. I always do it in the same order, but I don't have to as long as I do a derivative times an original. The quotient rule, it has to be the derivative of the top first. So you work your way from the top to the bottom. That's how I remember it. Derivative of the top, original bottom, minus the derivative of the bottom, times the original top, all over that original bottom gets squared. You start out with a fraction for quotient rule, and your answer is a fraction with a quotient rule. So you divide it all by the original bottom squared. So product was always plus, quotient is always going to have a minus. Product is plus, quotient always has a minus. So it's a long rule, but again, we're just doing a derivative times an original. And as long as you know those basic derivatives, it's not too bad. Let's try it on this one. We're given f. It has x's in the top and the bottom, and it's divided, so I know I have to use a quotient rule. So I'm going to do the derivative of the top first. I have x to the 5th minus 6x, so I have 5x to the 4th minus 6 for the derivative of the top, times the original bottom is x cubed plus 4. Derivative of the top, original bottom, minus for quotient, the derivative of the bottom. Derivative of x cubed is 3x squared. Derivative of plus 4 is 0 because it's a constant. And now this is one term, so technically doesn't need parentheses. I always use parentheses on quotient rule, just to be careful. Put everything in parentheses. Derivative of the top, original bottom, minus derivative of the bottom. I need the original top with it. A derivative gets an original for both the product and the quotient. All over the original bottom gets squared. And I know this is a long rule. If you look up on like YouTube, there are songs that are like row your boat, quotient rule. You can try to find people sing songs about this. I'm doing you a solid favor by not singing to you. I'm going to keep saying it over and over again though so that it sticks. Derivative of the top, original bottom, minus derivative of the bottom, original top, all over the denominator squared. Okay, let's use that a few more times here. So the next one I have is g of x. I'm going to call the derivative g prime of x. You don't want to lose small points by just forgetting to label things, so just make sure you label your derivatives. And first thing I do is I work my way from the top to the bottom. So I need the derivative of the top first. X squared plus 3 has a derivative of 2x, and the derivative of 3 is just 0. So derivative of the top, original bottom, e to the x minus ln of x. Product is always plus. Quotient has a minus between these derivatives and originals. Now I need to take the derivative of the bottom. Derivative of e to the x is e to the x, minus the derivative of the natural log of x is 1 over x. Derivative of the top, original bottom, minus derivative of the bottom times the original top. Derivatives always have an original next to them, multiplied. Last thing, you start with a quotient, you end with a quotient. E to the x minus ln of x squared. The original denominator gets squared. It's super long, but it's way shorter than doing that 4-step process to finding a derivative, so it could be worse. Okay, this next one looks a little bit harder just because I see rule 6 snuck in here. That was the one I had you guys put a star on, and that's just because it comes up a lot. So I want to take the derivative. I'm going to call it h prime of x. Always do the derivative of the top first. So the derivative of e to the 2x comes from doing the derivative of the power, derivative of 2x is 2, times e to the original power. And then the derivative of negative 1 is just 0. So here's my whole derivative of the top. I need the original next to it, original bottom, minus, always for quotient rule, product is plus, quotient is minus. And then derivative of the bottom, derivative of the natural log of x, it's always 1 over x. Derivative of 3 is just 0. This is a derivative. It needs the opposite original. So I need e to the 2x minus 1. Derivative of the top, original bottom, minus derivative of the bottom times the original top, all over the denominator squared. Original denominator, original bottom gets squared. So maybe try the next one. It has some good review of some of those harder to remember basic derivatives, but the quotient rule stays the same. Feel free to pause the video and try this next one. Finding y prime. We're doing the same thing. Derivative of the top times the original bottom minus the derivative of the bottom times the original top all over the denominator squared. See if you can fill out those pieces. So for the derivative of the top, the derivative of the natural log of x is 1 over x minus 30x to the 29, bringing down the power and subtracting 1 for the new power. There's the derivative of the top. Original bottom is 8 to the x plus 4x. Minus, now I get to take the derivative of the bottom. Derivative of 8 to the x is ln of 8 times 8 to the x, plus the derivative of 4x, that was our mini rule, derivative of 4x is 4. Derivative of the top, original bottom, derivative of the bottom, original top. ln of x minus x to the 30. All over the original denominator is 8 to the x plus 4x squared. There is our longest rule, but the more you know the basic derivatives, the easier it is to do this quotient rule. Just again, be careful. Don't do it for every single fraction you see. You do not have to do it unless you have x's in both the top and the bottom.